Good afternoon, class. So we do have a test tomorrow, so I'm going to review the multiple styles of solving quadratics. I'm just going to use one equation. I'm going to look at this equation, 2x squared plus 10x plus 8. And I'm going to solve it a bunch of different ways. The first way to solve it is going to be our classic factoring technique. Okay? I need two values that multiply together to give me 2x squared. Well, I know I can say 2x times x. And now I need multiple values that will multiply to give me a positive 8. Now, I'm going to get some options. I could have 1 and 8. I could have 2 and 4. I could go alternate and go 4 and 2, or even 8 and 1. And this is that portion where you have to kind of do a little guess and check. I see that this answer is positive and this answer is positive, so I know they're both going to have to be positive. And a couple of things I can look at, well, if I put a 1, let's go for instance a 1 and an 8 right here. Checking everything out when I FOIL it, I get 2 times 8 is 16, and I get 1 times x is 1x, which is 17x. Now, is 17x what I desired? I don't think so. Okay, so double check a couple of them. Luckily, we don't have too many options to have to go through. We can kind of FOIL and check everything out as we go along. Let's come in here and look at what the correct answer is. What I should have seen is if I put a 4 right here and a 2 right here. Again, 2x times 4 gives me that 8x, and 2 times x gives me the 2x, which does equal 10x, which is what I wanted. Now, recall a couple of things, class. We are trying to equal this to 0. We're trying to solve for this. Set equal to 0. That means we have two individual math problems. I had the math problem that says 2x plus 2 equals 0. And I had the math problem that says x plus 4 is equal to 0. We still have to solve these, but it's really not that bad. We can take the 2 away and divide by the 2, and we see that x is equal to -1 and x is equal to -4. Okay? Now, that was one option. That was by factoring. Now, we totally could have, and again, guys, feel free to rewind and pause this video as much as you need to. We could have solved this by grouping. I could have taken this 2 and 8 and said 2 times 8 is equal to 16. And I could have listed out factors of 16 that add together to give me 10. Right? Do we agree that 8 plus 2 is equal to 10? Now, I'm just going to rewrite this. 2x squared plus 8x plus 2x plus 8. I haven't changed anything except for the way it looks. The first term is the same, the last term is the same, and if I were to add these two terms, it would equal this middle term. But I did this for a reason, because now I can factor this by grouping. If I look at this first group, the greatest common factor between 2x squared and 8x is a 2x. And when I divide a 2x out, I'm left with an x plus 4. Again, 2x squared divided by 2x equals x, and 8x divided by 2x is equal to 4. When I look over here, what's the greatest common factor between 2x and 8? A positive 2 is the greatest common factor, leaving me, when I divide 2 out, x plus 4. This is like happy dance moment, because what happens? I get x plus 4 and x plus 4. That means I can factor out my x plus 4, leaving me with 2x plus 2. These leftover terms, they get to join forces, don't they? Okay? Again, this whole equation was equal to 0. It's still equal to 0. Well, that just means that I have two math problems. I had the math problem that says x plus 4 equals 0, and I had the math problem that says 2x plus 2. This should look so familiar, you're probably moaning and groaning. But we know that the answer is x is equal to -4 and x is equal to -1. Same as we got in the previous example, because it's the same problem. We just used a different technique. Now, don't forget, we could always go for the classic slide and divide, right? Where I'm going to completely write a new math problem, where I take that 2 and I multiply it all the way down to that 8 and I get 16. Now, again, brand new math problem, but this is a new math problem that will factor out much simpler, right? Mainly because x is a singular term. It's just x times x. Looking for factors of 16, well, a positive 2 and a positive 8 will work. And that tells me that x must be equal to -2 and x must be equal to -8. But wait, that was just the slide part. Now we have to do the divide part. What happens when I do x is -2 divided by 2? That says x is equal to -1. X is -8 divided by 2? That says x is equal to -4. 3 different techniques of factoring that all gave us the same exact answer. Now, what if the test or you just decided I don't want to factor? Well, you have a couple of other options. We have the classic quadratic formula. I want to write it, but I need Marcus to sing it. Marcus, sing it! I'm really hoping Marcus sang it. If he did, Marcus, you just got 5 bonus points. If you didn't, Marcus, you just lost 5 bonus points. All right. If we want to use the quadratic formula, we look at our coefficients. They always go in order A, B, and C. So we look at this, ready? We can say x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Okay? This can be simplified. We could use our calculator if we need to. Let's show it. It's going to be x is equal to -10 plus or minus. If you were to calculate this, the discriminant, you're going to find that it's 100 minus 64 all over 4. And when you do 100 minus 64, you're going to say x is equal to -10 plus or minus the square root of 36 over 4. Now, this is where that plus or minus sign gets very important. I know the square root of 36. It's 6. Okay, but remember, it's plus or minus. So it means that I'm going to have 2 math problems. I'm going to have this math problem, x is equal to -10 plus 6 over 4, and I'm going to have this math problem, x is equal to -10 minus 6 over 4. Okay? Good things will happen. This means that x is equal to -4 over 4, aka x is equal to -1. And this one says x is equal to -16 over 4, aka x is equal to -4. Okay? And we see that's the correct answer because we've already done this problem 3 times. But, alas, I think we should do it one more time. And this time, I'm going to do the completing the square technique. Now, we have done completing the square technique when we took quadratics and we put them in vertex form. And we always, always, always started by moving that constant, that 8, or whatever number we have over there, by moving it to the other side. Now, this, too, is a problem. We can't have him there. We need to factor him out, okay? Leaving me with x squared. Now, when we factor him out, that means we divided him out. So this is no longer a 10. Now it's a 5. And once we factor him out, we can now get this blank space, you know, a little Taylor Swift in this house. And remember, if we divided a 2 out, we must multiply a 2 back in. This is going to get a little icky, but hang with me. What goes in our blank space? It's going to be half of the middle term squared. Half of the middle term. So half of 5 is 2.5 squared. We do this for one reason and one reason only. This 2 will follow us. And now we can take this term and this term, because both of those are my squared terms. And we can write it both squared. See, again, this was squared and this was squared, so they're both squared. And now we can do a little bit of math. This is -8 plus, well, I would totally use a calculator if I were y'all, because that's going to be like a 2.5 squared all times a 2, and it's just going to be a little messy. And actually, I don't have the answer written down. I have this answer written down. I did the entire math problem. Again, make sure you use your order of operations. Use your calculator. 2.5 squared times 2 plus -8. Okay? And this is good. Now, if we wanted to put this in vertex form, I would bring this back over there. But I don't want to put it in vertex form. Instead, I just want to go ahead and solve for it. So I can use my basic order of operations and start peeling off these layers. Remember, I always say, I can't take my socks off until I take my shoes off. Okay, so divide that 2 out. 4.5 divided by 2. Let's see. I wrote this down. I did. It's 2.25, obviously. Gosh. And then I can take a square root to get rid of this exponential term. And this is going to give me x plus 2.5 is equal to the square root of 2.25. I recommend using your calculator. You'll be pleasantly surprised. But is it 1.5 or is it plus or minus 1.5? You are correct, guys. It is plus or minus 1.5. Make sure we keep that involved. This means we have two equations. I get x is equal to positive 1.5 minus 2.5, and x is equal to negative 1.5 minus 2.5, which will give me -1 and -4. The two answers we expect to see. Now you probably think, oh my gosh, there's no other way to solve these. I wish you would just stop. But there actually is one more way. We could use our calculator. Imagine we used a new document and we wanted to get a graph going on. I could graph this function, 2x squared plus 10x plus 8. Oh, wait, it didn't actually work. Oh, nobody panic. Nobody panic. Plus 10x. Oh, gosh. Okay, I'm panicking. Okay, I got it. Plus 10x plus 8. Okay? And look at this function. Now, you're probably thinking, like, what does that have anything to do with anything? Well, look at these x-intercepts. I got one of them over here at -1, and I got one of them right here at -4. Wait a minute. Didn't we say x is equal to -1 and x is equal to -4? We did. Because when we solve quadratics, what we're finding is just the x-intercept. You could always just look at it and find it on the graph, okay? All right, class, I hope this is informative. If you guys have any questions, post them on Edmodo. Do your review tonight and get ready for your test tomorrow. I think you guys are going to do great. This is Mr. Troop. Adios.